sklearnpreprocessingRobustScaler. Description: RobustScaler transforms features by removing the median and scaling the data according to the quantile range. This method is less prone to outliers in the data than the standard scaler. Inputs: X, a numerical array containing the features to be scaled. This can be a NumPy array, pandas data frame, or a similar structure. Outputs: X scaled, a transformed array containing the scaled features. The data is centered around 0 and scaled to a specified range. Steps: Calculate the median of each feature. Calculate the interquartile range IQR of each feature. The IQR is the difference between the 75th percentile and the 25th percentile. Center the data by subtracting the median from each feature. Scale the data by dividing by the IQR. Metrics: IQR interquartile range. Median, the central value of a sorted dataset. Visualization plots. Box plots visualize the distribution of the data before and after scaling. To assess the impact of the transformation. Scatter plots plot the features against each other to check for any potential distortions introduced by the scaling. Fine-tune parameters. With centering Boolean. Default true. If true, center the data before scaling. If false, do not center the data. Quantile range tuple of floats. Default 25.0. 75.0. The quantile range used to calculate the scaling factor. The data is scaled such that the quantile range is equal to 1. Uncertainty methods. Bootstrapping: resample the data with replacement to estimate the variability of the scaling. Parameters. Confidence intervals. Construct confidence intervals around the scaling parameters to quantify K. Uncertainty. Challenges and fixes. Challenge 1: the robust scaler can be sensitive to extreme outliers that lie outside the IQR. Sample use case that resulted in challenge 1: a dataset with a few extremely large values might cause the robust scaler to scale the data in a way that emphasizes these outliers. Fixes to challenge 1. Consider removing extreme outliers before scaling the data. Use a different scaling method, like the standard scaler, if the data has a Gaussian distribution. Challenge 2: the robust scaler can be less effective when the data has a skewed distribution. Sample use case that resulted in challenge 2: a dataset with a long tail on one side of K. Distribution might not be well scaled by the robust scaler. Fixes to challenge 2. Consider applying a transformation to the data to make it more symmetric before scaling. Use a different scaling method, like the standard scaler, if the data has a Gaussian distribution.